So, hello everyone. Today we see some more models in equilibrium. Okay, so see, so the three equations are given. Actually, man, ఇప్పుడు just a problem. So there was only two equations are given. We had to find the third one. But here the three equations, three informations are given. We have to find the fourth one. Okay, equilibrium constant for fourth equation. See the N2 plus 3H2 formation of N2NH3 is equilibrium K1. N2 plus O2 gives 2NO. It's equilibrium constant K2. H2 plus of O2 H2O gives rise H2O. Its equilibrium constant K3. We have to find the equilibrium constant for this reaction. So what is this? 2 ammonia plus 5H2 oxygen gives rise 2NO plus 3H2O in terms of K1, K2, K3. Means not the numericals. I have to find the relation between K1, K2, K3 and this fourth one. Okay. So actually మనం find out చేయాల్సింది this one. So మనం find out చేయాల్సింది first రాద్దాం. Okay. We have to find the equation. So K is equal. So here all our gases and O square or 582. So we have to find this one. So ఈ value now, so in terms of K1, K2, K3 to find out challenge. So for that we write the K1, K2, K3, then we will get so K1 into K2, K3 any multiplying, dividing any squares, cubes, then we will get it. So K1 is equal to NH3 square by N2 concentration, H2 power 3 concentration, power 3. Like second reaction, NO square, N2 and O2 all are power 1. Next, what is the third one? So already first two rases kabatti no need of this. What is the third one? K3. H2O power 1 by H2 concentration and O2 power 1 by 2. So these are the informations. Okay. So these are K1, K2, K3 are the three informations are given. We have to find this K value in terms of K1, K2, K3. See which are present in the numerators, which are present in the denominator, which are having the power 2, which are having the power 3. So on basis understand this course. Okay, we have to guess it. So like put the K1 by K2 next K2 by K3. So like the different methods మనం చేయొచ్చు, but observation guessing is the better one than the doing the total calculation. See, there is a NH3 square. Okay, NH3 square present in the equation. So this K1 in the numerator, but here NH3 present in the denominator. So I think so K we must get 1 by K1. So 1 by K1. Next here see NO power square is there. Same here also NO power square. NO square, NO square. So just we are observing any one of the species. So prati species ni compare cheyalem. So first K1 lo NH3 compare chestam, K2 lo NO compare chestam. Okay, NO numerator lo undi, square tho undi. In the information indi. So my question lo kuda NO numerator lo undi, power square undi. So I think directly that is equal to K2. K2 by K1. Next, what about K3? See here H2O. H2O present in the numerator. Here also H2O present in the numerator. But here H2O present power cube. Here H2 only 1 is there, power 1. So have to do cube this K3 cube. So it is the K value in terms of K1, K2, K3. K2 into K3 power cube by K1. So if you do all these calculation, you will get exactly this one. So try to do this. So K1, K2 direct rasedam. Okay, no doubt. So K1 reverse load add. So K1 reverse load add. So K1 reverse load rastunna. So what is the K1? Just I am checking the answer. And 2 plus H2. H2 gives 2 NH3. Okay, reverse system. Plus K3 ni cube cheyali. So K3 ni cube cheddam. This is 1 by K1 into K3 cube means okay. H2O whole cube. H2 whole cube. O2 power 3 by 2. This is K2 into 1 by K1 into K3 cube. Just e total calculation awesome. So finally we will get what? Here O2 power 1. Ikkada 3 by 2. So this becomes 5 by 2. O2 we got it. So N2 there is no N2 actually. So N to N get cancelled. There is no NH, sorry, NH3 square. NH3 square is also there. H2O cube is there. NO whole square, NO square is there. Means just by doing the K2 by K1 into K3 cube, we get the K value. Okay, just by observation, it's become very easy. Okay, see the next problem. So here the two equations are given. With the help of the two equations, we have to find the equilibrium constant of the third equation. It is given in terms of numericals. So first CuO solid, H2 gas gives rise Cu solid, copper solid, H2O gas. Here given K equals 67. In the second equation, CuO solid plus CO gas gives rise to copper solid, carbon dioxide in terms of gas 490. I have to find this. So here all our gases are present. So in the same model, actually it is a easy one compared to the first one. So now find out charge in K తీసుకుందాం. So K equal we have to find the product concentration. All are in the gaseous state. Power 1 only. So how to obtain this K? So direct we have to find the numerical ichina, direct relation find out cheyalani ichina, we have to find the relation at first. So after getting the relation only we are able to substitute the numerical values. So what is the K1? K1 H2 concentration pi. So it is solid. Here also it is solid. H2. So just write it as a K1 only. Next, what is the K2? K2 it is a solid. Next, CO2 concentration. Next, here also solid, CO concentration. How to get equation 1 with the help of K1 and K2? See, simple. It is looking very simple. H2 in the numerator, H2 in the numerator, H2 in the denominator, H2 in the denominator. So K is equal direct to K1. CO2 in the numerator. Sorry, CO2 is in the numerator. But in the question, actually this is we have to find. So CO2 K2 low CO2 present in the numerator. But we need to the CO2 in denominator. So we will find out in that low CO2 term denominator low. Okay. But each clue information, the second equation information low CO2 present at the numerator. Since here CO manaki the question we have to find our required CO is at numerator, but the given CO is at denominator. So we have to do reverse to the K2. So therefore K2 is equal to, so K1 by K2. Just we have to guess it. So maximum, if it's not possible to guess it, then only try to do the calculation type. So K1 by K2. So if you want to check it, you can check it. So final K is 67 by 490. So 0.14. Okay. So try to maintain the perfect notes for these problems. See is one more problem. It's very simple. So the equilibrium constant of 4 different reactions are given. That is 10 power 6, 10 power minus 4, 10 power 1. This is only one. This we have to find which reaction will take maximum time to get the equilibrium. Nothing but to attain the equilibrium. So actually manaki so ikkada k value comparison ga there are two type of questions are there. So some questions lo endante which is reaction is ready to completion. Okay, which reaction is so is near to completion. 100% completion for any reaction is not possible. Reversible reaction 100% completion is not at all possible. So which is maximum to completion listed, which is maximum to completion, which is near to completion ante so k value highest ఉన్నది తీసుకోవాలి. సో k value అంటే మనకి product concentration by reactant concentration. So k value highest ఉందంటే product concentration will be more. So product concentration దేంట్లో highest ఉంటే that is near to the completion అనొచ్చు. So but here the question is how much time, so how much time, how much which reaction will take maximum time to get the equilibrium. So ikkada k value less ఉంది యాక్చువల్గా. సో k value less ఉన్నది ఆన్సర్గా తీసుకోవాలి. k value less ఉందంటే మీనింగ్ ఏంటిది, ప్రోడక్ట్ బై రియాక్టెంట్ కాన్సన్ట్రేషన్, ప్రోడక్ట్ కాన్సన్ట్రేషన్ బై రియాక్టెంట్ కాన్సన్ట్రేషన్ టోటల్ వాల్యూ లెస్ ఉంది. అంటే టోటల్ వాల్యూ లెస్ ఉందంటే మనకి న్యూమరేటర్లో ఉన్న ప్రోడక్ట్స్ ఆర్ వెరీ లెస్. సో ప్రోడక్ట్స్ ఆర్ వెరీ లెస్ ఉందంటే ఇట్ టేక్స్ మోర్ టైమ్ to get the equilibrium. Means here, so this is the total theoretical question, that is no matter. So it is so what is the answer is so the reaction, so the reaction with K2 is equal to 10 power minus 4 will take maximum time, will take max time to achieve equilibrium. So which is near to completion reaction ante so that is 10 power 6 because it is at the highest value. Okay, see the problem in terms of graph. So actually this type of problems are, many number of these problems are there in the book. So we see one or two models. See first the reaction is given 2 moles of nitrogen dioxide is decomposed to 2 moles of NO and O2, all are in terms of gases. So for this reaction, so equilibrium reaction is represented in terms of graph. సో ఈ గ్రాఫ్లో మనకి ఎక్స్ కామా వై కామా జెడ్ 3 కర్వ్స్ ఇచ్చాడు. సో ఎక్స్ కర్వ్ దేని రిప్రజెంట్ చేస్తుంది, వై కర్వ్ దేని రిప్రజెంట్ చేస్తుంది, జెడ్ దేని రిప్రజెంట్ చేస్తుంది, వీ హ్యావ్ టు ఫైండ్. సో వెరీ సింపుల్ వన్. సి ఎక్స్, సో ఇక్కడ మనకి యాక్చువల్లీ ఇట్ ఇస్ అ కంపారిజన్ విత్ కాన్సన్ట్రేషన్ అండ్ టైమ్. సో యూ నో దట్ as the time increases, concentration of the reactants decreases. So in the introduction we discussed for any reaction, so starting లో reaction fast ఉంటుంది. ఓకే, స్టార్టింగ్ లో రియాక్షన్ ఫాస్ట్ ఉంటుంది ఎందుకంటే కాన్సన్ట్రేషన్ చాలా జీరో టైం కాబట్టి వెరీ హయ్యర్ అమౌంట్ ఆఫ్ ఫుల్ కాన్సన్ట్రేషన్ ఉంది అక్కడ. సో అట్ ద టైం 0 సెకండ్ 1 సెకండ్ 2 అలా టైం ఇంక్రీజ్ అవుతూ ఉంటే ఏమవుతుంది, సో ఫస్ట్ ఉన్నంత స్పీడ్ నెక్స్ట్ రియాక్షన్ ఉండదు బికాజ్ కాన్సన్ట్రేషన్ స్లోలీ డిక్రీజింగ్, రియాక్షన్ ప్రొసీడ్ అవుతుంది కాబట్టి ఇస్ కాన్సన్ట్రేషన్ డిక్రీజెస్. అంటే యాజ్ ఎ టైం ఇంక్రీజెస్, యాజ్ ఎ టైం ప్రొసీడ్స్ the concentration of the reactants get decreased. Okay, simple. So you can decrease in a line only one only, that is a z line. See the z line. So starting 0 time. So 0 time. So y axis 0 time. 0 time దగ్గర highest concentration ఉంది. As the time increases ఈ graph ఏమైందంటే down అయిపోయింది. So towards one day, so as the time increases, concentration decreased. Means nothing but the z indicates about the reactants. So we can understand. So here z represents reactants. So how you are getting that indicates reactants means because as time proceeds, the concentration of reactants decreases. So exactly Z represents the reactants. Like simply automatically what about X and Y? X and Y indicates about the products. Because as the time increases, so starting 0 time the grass 0 concentration only. As time proceeds, the concentration of X increases, Y increases. So our line at X comma Y line indicates about the products. So reactants ఒకటే ఉంది కాబట్టి there is no doubt. Simple గా మనం so it indicates about reactants that is indicates about the NO2. But ఇక్కడ X comma Y represents the products, but products లో NO product ఉంది, O2 product ఉంది. It's very simple. So it is in higher number of moles, it is in low number of moles. Normally concentration in terms of moles all are present in the same vessel. Reversible reaction kabatti taken in a closed vessel. So all are present in the gaseous state kabatti closed vessel avuntadi. All are having same volume. So the number of moles highest undi. Number of actually mana concentration ante moles per liter తీసుకుంటాం. So the number of moles 2 and number of moles 1 undante. So automatically its concentration. So the NO concentration will be higher than the O2 concentration. So ఇప్పుడు కాబట్టి ఇక్కడ higher concentration. So high concentration ఉన్న line ఏంటిది? X means XO represents NO2. So Y represents O2. Okay. So here X comma Y represents products. So why you are taking like this means because as time proceeds, concentration of products decreases. Therefore here X equals NO and Y is equal to what is that? O2. How it is means and O2 is with only one mole, means it is a lesser value. So very highest position on the kabatti highest position X ki X will be represented NO. So Y represented then below that is the O2. Okay. Okay, let's see the last one more problem. So here also the two equations are given. We have to find the relation between the K1 K2. So here, so some difference is there. So I have to first find what is the K1. So then only we can guess the relation. So first one I am writing So concentration of products by concentration of reactants. So equation 1. So what is K2? So K1, K2 no need to write again the equations. So what is K2? NH3 power 2 by 3 by N2 power 1 by 3 H2 power 1. So I have to guess the relation. So just see here K1 NH3 numerator, in here also NH3 2 by 3. So here 2 by 3 only, numerator. So N2. So the numerator terms. So ఇక్కడ న్యూమరేటర్స్లో ఉన్నాయి, డినామినేటర్స్లో ఉన్నాయి. సో కాబట్టి we will get the direct relation వస్తుంది. So K1 is equal to K2 or K2 is equal to K1. You can write anything. So ఇప్పుడు పవర్ చెక్ చేద్దాం. So ఇప్పుడు this is only power 1. So దీనికి if you make it 2 by 3. So దీన్ని 2 by 3 చేద్దాం. So K2 power సో K1 ఈక్వల్స్ సో ఇక్కడ 1 ఉంది మనకి. సో జస్ట్ ఏదో ఒక 1 స్పీసీస్ తీసుకొని దాన్ని ఈక్వలైజ్ చేయడానికి ట్రై చేద్దాం. ఓకే, దాన్ని వచ్చిన న్యూమరికల్తో మిగతా వాల్యూస్ కూడా చేస్తే ఇట్ ఈస్ సాటిస్ఫైడ్ ఆర్ నాట్, వి చెక్ ఇట్. సో ఇక్కడ NH3 పవర్ 2 by 3 ఉంది, ఇక్కడ NH3 పవర్ 1 ఉంది. సో ఇక్కడ కూడా పవర్ 1 తీసుకుందాం. జస్ట్ 2 by 3 పవర్ 1 అవ్వాలంటే జస్ట్ మల్టిప్లై విత్ 3 by 2. 2 to get cancelled అంటే పవర్ 1 అంటే K2 పవర్, ఐఎమ్ జస్ట్ థింకింగ్ K2 పవర్ 3 by 2 చేస్తే we will get the answer. సో దీన్ని కూడా 3 by 2 చేద్దాం. సో మేక్ ఇట్ 3 by 2. సో 3 by 2 చేస్తే 3 get cancel. See 3 by 2 చేయండి, 3 by 3 get cancel become 1 by 2. సో 1 by 2 పవర్ 1. సో దీన్ని కూడా 3 by 2 చేస్తే ఇంటూ 1 ఉంది. సో 1 into 3 by 2 3 by 2. సో జస్ట్ అంటే దిస్ K2 పవర్ 3 by 2 చేస్తే వీఆర్ గెటింగ్. సో K2 పవర్ 3 by 2 చేయండి. సో దట్ ఈస్ NH3 ఆల్రెడీ 2 by 3 ఉంది. సో పవర్ 3 by 2. సో N2 పవర్ 1 by 2 ఉంది. సో అగైన్ 3 by 2 into H2 పవర్, సో H2 పవర్ 1 ఉంది. సో 1 into 3 by 2. సో జస్ట్ this calculation. So 3 by 2, 2, 2, 2, 3, 3 get cancelled. So NH3 power 1. So this 3 by 2, sorry, ఇక్కడ 1 by 3 ఉంది, not 1 by 2. Here 1 by 3 is there. So again 3, 3 get cancelled, 1 by 2. So overall we will getting 1 by 2. So ఇక్కడ already 3 by 2. So this is exactly equal to equation 1. So nothing but equation. So this is the equation of K1. అంటే సో K1 K3 మనం పవర్ 3 by 2 చేస్తే we will get K1. సో K2 ని 3 by పవర్ 3 by 2 చేస్తే we will get K1. Okay, just we are guessing these values. So otherwise you can do K1 by K2 చేస్తే we will get somewhat big calculation, but afterwards also we will get the same answer. Okay, so tomorrow we see some more problems. So it is compulsory that you need to maintain the clear notes for these problems, because within few days we will check it in the school.